Hi and Assalamualaikum. So now I will explain the introduction what is Newton's law. Newton's law of motion are three basic laws of classical mechanics that describe the relationship between the motion of an object and the forces acting on it. This law can be paraphrased as follows. First, Newton's first law. Next, Newton's second law. Last but not least, Newton's third law. The three laws of motion were first stated by Isaac Newton in his Philosophiae Naturalis Principia Mathematica in column Mathematical Principle of Natural Philosophy. Originally published in 1987 year, Newton used them to investigate and explain the motion of many physical objects and systems, which laid the foundation for classical mechanics.
So first of all, let's take a look at Newton's first law. In fact, in classical Newtonian mechanics, there is no important distinction between rest and uniform motion in a straight line. They may be regarded as the same state of motion seen by different observers, one moving at the same velocity as the particle and the other moving at constant velocity with respect to the particle. This postulate is known as the law of inertia. So, as a summary for Newton's first law, an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Next, we have Newton's second law. Newton's second law is a quantitative description of the changes that a force can produce on the motion of a body. It states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the product of its mass and its velocity. Momentum, like velocity, is a vector quantity having both magnitude and direction. A force applied to a body can change the magnitude of the momentum or its direction or both. Newton's second law is one of the most important in all of physics. Basically, Newton's second law is a force applied to an object at rest causes it to accelerate in the direction of the force. Lastly, we have Newton's third law. Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it also applies to bodies in uniform or accelerated motion. To summarize Newton's third law, we should understand that forces always act in equal but in opposite pairs. So why do we use Newton's law? First of all, we use it to understand the relationship between the motion of an object and the forces acting on it. We also use it to help us accurately calculate the force or motion connected to a certain action. It also helps us in increasing our understanding in the applications of Newton's law in real-life situations.
Next, let's move on to the discussion. In this video, we will provide two examples of application Newton's law in real life. So, let's take a look of question 1. Question 1, problem statement 1. Today is the best day to go on vacation. Ahmad went on vacation while towing a caravan using a car. Ahmad needs to bring the car fast to reach the plane time. A car of mass 1,300 kg is pulling a caravan of mass 700 kg. The driving force exerted by the car is 1,500 Newton and there is no resistance to a motion. So, the question is, we need to find the acceleration of the car and the caravan. Also, the force in the tow bar between the car and the caravan. How to solve this question? The question can be solved by using 3 steps. Step number 1, draw and label the diagram based on the problem statement. Step 2, write the formula F equal to ma and input the value to find the acceleration for the system. Step 3, substitute the value of acceleration to find the force between car and the caravan. Here is the problem solving for question 1. For the step 1, we need to draw and label the diagram based on the information that given to us in problem statement 1. From the diagram, we can see the applied force for this system is 1,500 Newton and for the mass of caravan is 700 kg and for the car is 1,300 kg. And for the acceleration in this system is unknown. So, to find the acceleration, we can use the formula F equal to ma, which is F here is the applied force equal to 1,500 Newton. And for the mass, we need to add up both caravan and car mass and got 2,000. To find the A, we need to divide F applied force divided by mass, total mass of caravan and car. And then A here we got 0.75 meter per second per second. By using A 0.75 meter per second, we need to find the force between car and the caravan, which is the tension force. To find the tension force, we can use formula F equal to ma, but for the F here is the different because we need to minus it with T, because applied force and tension force is the opposite direction. And for the mass, we need just car mass because the tension for both caravan and car are the same. And then by using all the values, we substitute it into the formula and then we got T equals to 525 Newton.
Okay, for problem statement 2, we have here Ame has a younger sister. His younger sister name is Amira. Every evening, Ame would accompany his younger sister to play at the playground. His younger sister loves to play sliding. The surface of sliding is at 35 degrees with the horizontal and mass of his younger sister is 55 kg. So we need to find the acceleration of the younger sister and the normal force. So, how do we solve this question which is connected with Newton's third law? Okay, the first step to answer the question is step 1, which is to draw and label the free body diagram. By drawing the free body diagram, we will be able to see the details in the question more clearly. And then we will follow it with the second step, which is to calculate the diagram Wy and Wx component which is needed in both formulas. And then finally, we will need to insert the Wx and Wy component in the formula F equals to ma to find the acceleration and using R equals to mg cos theta to find the reaction force. Now, let's apply it into the given question. To the question, we are able to gather that the slide has an inclined plane of 35 degrees and Amira has the mass of 55 kg. First of all, we should draw the actual diagram of the action, then from it we will be able to turn it into a free body diagram which shows where that forces are connected to in the diagram. After that, we will need to calculate the component of the weight which is Wx and Wy. To find Wx, we will need to insert it into mg sin theta, which m is the mass of Amira, g is gravity with the fixed value of 9.81 and sin 35 by inserting the given angle. We will get the Ws equals to 309 Newton. For the Wy is the only difference for the formula is to switch the sign into cos, which we will get 442 Newton. Lastly, by inserting the Ws into the formula of F equals to MA, it will turn into mg sin 35 equals to 55A. And because we already found mg sin 35 by reinserting it into a formula, we will be able to get A equals to 5.61 meter per second square. Next, for the normal force, which is also known as direction force, is R equals to mg cos 35, and we will get 442 Newton.
Next, we move on to conclusion. Newton's three laws of motion can explain all aspects of an object's motion. Firstly, his first law explains that forces are necessary to change the motion of an object. Next, his second law describes how forces and acceleration are related to mass. However, his third law explains that forces act in pairs. Everyone should at least have a basis of knowledge of Newton's law to understand the motion that happen in real life. Last but not least, hopefully other students can understand more about the Newton's law from our video. That's all from us. Thank you.